Chapter 12, Section 4 is about angle measures and segment lengths. The first thing we're going to talk about is if an angle is formed with its vertex on the circle, then the measure of that angle is equal to half the measure of the intercept arc. That's what we talked about last time in Section 12-3. So we had inscribed angles are 1/2 the measure of the intercepted angles. But what if the vertex does not lie on the circle? There are two possibilities. So we might have a secant, which is a line that intersects a circle in 2 points. So this is a line here, and it intersects the circle in 2 points. So in here, inside the circle, we have the chord. But the line, if it's a whole line, that's called a secant line. Theorem 12-11 says that angles inside and outside of the circle theorem. So we can have a vertex on the inside. So this vertex here is on the inside of the circle, but it's not at the center. So we need to think about what the measure of this angle will be. Well, it's not an inscribed angle, so it won't be half the measure of the intercepted arc. And it's not a central angle, so it won't be the actual measure of the arc. So what it will be is the measure of this angle 1 will be 1/2 the sum of the intercepted arcs. So the two intercepted arcs in this case is this angle, or this arc here, and this arc. So it will be the sum of these two and then 1/2 of that. That's for when the vertex is on the inside of the circle. Then we go over here to where the vertex is outside the circle. So this vertex of this angle here is outside the circle. So in this case, we need to also figure out what the measure of that angle will be. The measure of the angle when the vertex is on the outside is going to be 1/2 the difference of the intercepted arcs. So here, this illustrates this idea really well. We need to take the difference of the yellow arc and the orange arc. So these are both intercepted arcs, but we don't want to take, so here when the vertex was inside, here we took the sum. But now when the vertex is outside, we're going to take the difference of this larger arc and this smaller arc. So we have the yellow arc minus the orange arc. So let's look at some examples of those. So here we have the inside, so we're going to have the measure of the angle is 1/2 the sum. So that's a good way to remember, is the measure of our angle is going to be equal to 1/2 the sum because this is on the inside. So we have this intercepted arc and this intercepted arc, so we're going to add those two together and we're going to multiply by 1/2. So 1/2, 88 plus 86, that gives us 87. So that means this angle here is 87 degrees. Now if we look at this example too, this vertex is on the outside, so we know that we're going to need to use the measure of the angle is going to be equal to 1/2 the difference of the two intercepted arcs. So it gives us that this arc is 150 and this arc is 60. And then we need to find the measure of angle x. It's going to be the measure of this angle right here, x, is going to be equal to 1/2 the difference, so 150 minus 60. That's going to give us 45. So the measure of x is going to be 45 degrees. So moving on to example 3, we have this. This vertex is outside the circle, so we know we're going to have the measure of the angle equal to 1/2 the difference. First, we need to decide if we have all the pieces we need for this equation. So all we know here, this is written in later on, is that this whole entire arc is 220 degrees. So we want to know x. That means that this arc left over, which is what we need, right? Because we need the difference of this arc and this arc, because this is where it hits, this angle here hits the circle right here. So we know that this would be 220, the whole thing, minus this little portion, x. So we have this arc can be called 220 minus x. So now we already know that this angle here is 38 degrees. So that goes in this place of our equation. We have that 38, this angle equals 1/2 the difference of these two arcs. So the difference of these two arcs would be the larger one, 220 minus x, and then we subtract x, which is the smaller arc. Now when we just do the algebra, we have minus x, so we get 220 minus 2x, and then we're multiplying by a half. So in order to get rid of this half, we're just going to multiply by 2 on both sides. We get 76 equals 220 minus 2x. Solve out this equation, and we get negative 2x equals negative 144, and we get x equals 72. So the measure of this arc is 72. And we were already given this, so we weren't trying to find the measure of the angle. Again, we're going to do that here. So in example 4, we have again that the vertex is on the outside. So right away, we're going to write the measure of the angle is equal to 1/2 the difference, because we want to make sure we know when to use the sum and when to use the difference. When we use the sum, the vertex is on the inside. And then when we use the difference, the vertex is on the outside. So again, the measure of the angle is this angle that we're talking about. So we're going to put 60 in there. Then we have 1/2. And in this case, it's the entire circle. It didn't even give us that it was, in this case, it gave us it was 220. This, we know that is, the whole thing is 360. So x is this part from this point to this point where it hits the circle. And the rest is going to be 360 minus x. So it's very similar to the last example. We have 1/2 360 minus x, and then minus x, because that's the difference piece that we're talking about here. So we have 60 equals 1/2 360 minus 2x. We solve it out, and we get x is equal to 120. Now, it might ask you for something like, what is the measure of the major arc? So that is talking about this, what we've talked about before in a previous chapter, this arc that's larger than a semicircle, larger than 180. So we would just take 360 minus 120, and we get 240. Okay, now we need to talk about the power of a point. So if we have a point here, this point Q, that lies inside the circle, and you draw this line, or part of a line, just like a segment here, through that point, then there are two distances along that line to a point on the circle. So if we draw this line here, there's this distance from the point Q to the circle, to a point on the circle, and then another distance from this point Q to the point on the circle. So I have 3 and I have 8. So we're going to talk about the power. The power of that point is the product of these distances. So we're going to multiply 3 times 8, and that will give us the power of this point Q. Now, the product of these distances along any one line is always the same. So these distances here that also pass through Q will also give us the same power. So 6 and 4 also give us a power of 24. That's how it will always be. This product will always be the same for the distances along any one line. So again, we have 12 and 2. That also gives us a power of 24. So another thing is, if the point lies outside the circle, the same thing will apply. There are two distances along the line to the circle. The product of these two distances is also the same no matter how you draw the line. So we can have the two distances look like this, or like this from this point P. This point P, this point P. Let's check out a few examples of this. So if we need to find the value of each variable in this diagram, we would use that we know the power of this point here, this point that lies inside. So the power of this point will be 2 times x, and it will also be 8 times 2.5. So we're going to so we have 2 times x equals 8 times 2.5, because the power will be always the same. So we know that the power of this point is 8 times 2.5, that's 20. So 2 times x, whatever x is going to equal 20. So we know that if we divide by 2, x equals 10. So now if we multiply 8 by 2.5, we get 20. And if we multiply 2 times 10, we get 20. So the power of this point is always going to be 20. So now let's look at these examples where the point is outside of the circle. So the power, though, is not equal to 18. It's not 2 times 9. The power is going to be this distance here, from the point to this point on the line here. And then it's going to be from this point to this point. So it's going to be 2 times and then this whole length. So we need the length of this whole thing because it's the power, again, if we go back up here, the power is the product of these distances. What were these distances? 2 distances along that point, or along that line, from that point to a point on the circle. So this point Q to the point on the circle. So in this case here, we have this distance here from this point, from the point here that we were talking about, the power of this point, to this point on the circle, so we have that distance, and then from this point to this point on the circle. So we have this whole distance, so we have to add this part and this part. So in this example, the power is going to be this distance, 2, and then this whole distance from this point all the way to the point where it hits the circle. So that's 11. So now for this case, which is something that maybe should have been written up here, was that if this is a tangent line here, then we know that if this length here is y, then the power will be y times y. So that's y squared. So in this case, the power we found out already was 2 times 11, this whole length, and that's going to be equal to y times y. That's for only when it's a tangent line here. Otherwise, it's just going to be how you would normally do it, just like how we did 2 and then 11. So we'll see those examples down here. But for this case, when it's a tangent line, you're going to have 2 times 11. That's the power that we found out using what we learned up here. And then we have y squared. So we have y squared equals 22. And then we just take the square root of both sides. We get the square root of 22. We'll just put that into our calculator and we get that it's approximately 4.7. Okay, now then example 3 here, we're going to do 5 times, and then again we need to do this whole distance, 15. It's not going to be 5 times 10 because 10 isn't the whole distance from this outside point to the point on the circle, because the power is that distance, the distance from the point to a point on the circle. So it's going to be 5, this length, times 15, this whole length. And then that's going to equal 4 times this whole length. This whole length we can call x plus 4, because it's this chord plus the little 4 here. So we have x plus 4, so 4 times x plus 4. We just distribute, and we go through and solve, and we get that x is 59 divided by 4. Plug that into our calculator, and we get that it equals 14.75. Then again, another example here. So it gives us that this is 8, this is y, and then this is 7, and this is y plus 3. So we're going to have 8 times this whole distance, y plus 8, equals 7 times this whole distance, which is 7 plus y plus 3. So we wrote 7 plus y plus 3, so 7 plus 3 is 10. So you can just write y plus 10 if you can just add these two. So then we just go through and solve, and we get y equals 6. So that's just finding the power of the point. So knowing that you need to, if it's in the inside, all you need to do is just multiply these two together and then have it equal these two together. Multiplied together. It's the product of these two distances. And then the only special thing here with this one was that if you have, it's a tangent here, then you need to make sure you know that it's going to be this distance times itself. Instead of doing two different distances, it's just y squared, because you're just doing y times the same thing, y, instead of doing 2 times a different distance, 11. That's the only trickier part here, is it won't say, it will say this is a tangent, but then you need to remember that you just need to do y times y, or whatever this distance is. It might be a number, 7 times 7, so then you'd have 49 equals maybe 2 times x or something. So hopefully this made sense. If you have any questions, please bring them to class. Thanks.